What is the thermocline in ocean mixing? Have you ever wondered how the ocean's temperature changes as you dive deeper? The thermocline is a fascinating layer that plays a big role in ocean mixing. So, what exactly is the thermocline? It is a distinct layer in the ocean where the temperature drops rapidly with depth. This layer separates the warmer surface waters from the colder waters found deeper in the ocean. Typically, the temperature can drop from around 20 degrees Celsius near the surface to about 2 degrees Celsius at depths close to 500 meters. This temperature gradient acts as a barrier between the upper mixed layer and the deep ocean. For marine life, the thermocline is very important. It shapes marine ecosystems and affects how nutrients are distributed in the ocean. The warmer surface waters are often nutrient-poor, while the colder waters below are rich in nutrients. This nutrient difference influences the growth of primary producers like phytoplankton, which thrive in the sunlight near the surface. However, they rely on nutrients that can be limited above the thermocline. The thermocline also affects the distribution of marine organisms throughout the food web. For example, zooplankton and larger predators depend on the availability of these primary producers. Ocean mixing across the thermocline is limited because the temperature difference creates a density barrier. This barrier reduces vertical water movement, which means that nutrient exchange between the deep and surface waters is restricted. As a result, biological productivity in surface waters can be limited. However, ocean currents and turbulence can sometimes break down or weaken the thermocline. When this happens, nutrient-rich waters can mix upward, leading to bursts of marine life and biodiversity. The depth and strength of the thermocline can change due to seasonal and geographic factors. In tropical regions, the thermocline is often more stable and pronounced. In contrast, in colder polar regions, it may be weak or even absent. Seasonal changes, like surface heating in summer, can make the thermocline shallower and stronger. Conversely, winter cooling and storms can weaken or eliminate it temporarily. Changes in the thermocline, especially those driven by climate change, can have important effects on marine ecosystems. A shallower or altered thermocline can shift where marine species are found, affect nutrient cycling, and change how food webs function. For marine animals, this means potential changes in their habitats, feeding grounds, and breeding areas. Monitoring the thermocline is essential for understanding and managing ocean health and fisheries productivity. In essence, the thermocline is a key layer in the ocean that controls temperature stratification and limits mixing between the surface and deep waters. Its presence shapes nutrient availability and the distribution of marine life, making it a vital factor in ocean mixing and marine ecosystem dynamics. Understanding the thermocline helps us see how marine animals interact with their environment and how changes in ocean conditions might impact them.